Hi everyone and welcome to my channel. In this video we're going to discuss bias and variance trade-off. And when we are building a machine learning model, we want to come up with a good model that will be able to learn effectively on the patterns in the training data, and it will be able to generalize well to also new and unseen data rather than just the training data that we've been used to building the model. This will require the model to also avoid memorizing so much of the training data, and also capturing patterns that are irrelevant in the training data. So what is bias and what is variance? Bias is the difference between the predicted value and the expected value. When you're building a model, we'll come up with predictions that will be able to compare with the expected value. In linear regression, we saw this where we are calling it the residuals, the difference between the actual and the predicted. And each model makes assumptions during the training, and these assumptions may not hold during the test. If we end up having a higher bias model, the model will oversimplify the problem, and this will result in underfitting, failing to capture the patterns. Think of it where we are having curved data and we are fitting a straight line. So we've oversimplified the problem. Some other causes include incorrect assumptions between the relationship features, and also lack of enough features or expressiveness in the model such that the model does not learn well on the data. On the other hand, we have variance, which is now the model takes account too much on fluctuation or noise in the data, and it's getting to memorize data points that are not of importance, and learning on them, this results to overfitting the data, and they will perform poorly on unseen data. This will is caused by also insufficient training data. This or poor generalization techniques in the training of the model. So if we end up having too simple model, we create a situation where we are having a high bias and a low variance. On the other hand, when we overcomplicate things, if our algorithm is too complex, then we may result to having a high variance and a low bias. So what can we do? What can we do in a situation like this where we want our model to perform well and generalize well on unseen data? So we come up with a trade-off. We have a trade-off, and this trade-off is where we are having not so much complexity and also not so much error. We are having not so much bias and not so much variance. And the middle point is now where we call the bias variance trade-off. This is important because now our model will be able to generalize well in the unseen data. And also in practice, we can be able to achieve this using regularization techniques. Also, we can do cross-validation to avoid overfitting. Also, we can take time and just get to understand the data and perform really good feature engineering, which will enable us to enrich our features and not end up oversimplifying our situation. There we have it, guys, and we've been able to discuss the difference between bias and variance and the importance of the bias variance trade-off. Till next time, stay safe, guys.